Hello, Assalamu alaikum. Today I'm going to discuss with you some problems from conics and mechanics. First of all, here I'm going to show you a problem and its solution from conics. Here we are given to a stem here. This is first and this is second. First, we have to find the equation of the asymptotes of the hyperbola, and also we have to find the equation of directrix of stem 1. Then from the figure of stem 2 is parabola and vertex A, and then we have to determine the length of CB. Okay, so first of all, here we are given this equation of the hyperbola. We have to bring this 36 into right hand side, left hand side, and we get after that we get x square by 3 square minus y square by 2 square is equal to 1. If we compare this equation with standard equation of hyperbola, we get the value of a is 3 and value of b is 2. Then the transverse axis is along x-axis and conjugate axis is along y-axis. So the equation of the asymptotes are y is equal to plus minus b by ax. Okay, so this is our equation for the equation of the asymptotes, which is 3y is equal to plus minus twice x. Okay, now second, in this then we have to find the equation of the directrix of the stem 1. This is the equation, given equation. Then we have to then we have to convert this, and we get x minus 1 whole square by 5 square plus y plus 2 whole square by 4 square is equal to 1. If we convert this, we get x square by 5 square plus y square by 4 square is equal to 1. Comparing this equation with the standard form of standard equation of hyperbola, standard equation of conics, we get a is equal to 5, b is equal to 4, and a greater than 5. So here its eccentricity is root over a square minus b square by a square is equal to root over 5 square minus 4 square by 5 square is equal to 3 by 5. So equation of directrix will be x equal to plus minus a by e. From there we get x minus 1. If we substitute a, this capital X by x minus 1, we get 3x is equal to plus minus 25 plus 3, which is 3x minus 28, and 3x plus 22. Now part C. In part C we have to find the from the figure of stem 2 is a parabola, and the we have to find the vertex A. Then we have to determine the length of CB. Okay, this length we have to find out here. So now here given that the vertex of the parabola is 0, 4 and axis is parallel to y-axis, so equation of such parabola is x minus 1 x minus 0 whole square is equal to minus 4a times y minus 4, which passes through the point, this point. So x square is equal to 6 square is equal to minus 4a times 0 minus 4. So from here we get a is equal to 9 by 4. So and the equation of the parabola is x square equal to minus 4 times 9 by 4 times y minus 4. So x square equal to minus 9 times y minus 4. Coordinates of b is 3x, 3 and x, and as OC is equal to 3. Now b, which is 3 and x, satisfies the equation 1. We get 3 square equal to minus 9 times x minus 4. So 9 is equal to minus 9x plus 36. So b is 3 and 3, so x is 3. Again c is 30, so OC is 3 units. Okay, now Second, here the focus and the eccentricity is given of the ellipse. Eccentricity is root over 3 and the distance of the foci is 18 of the hyperbola. First we have to determine the length of major axis of the ellipse. X square by 8 plus y square by 4 is equal to 1. If the equation of the directrix of the ellipse of stem 1 is x plus 2y minus 1 is equal to 0, then we have to determine the equation of the ellipse. And taking the axis of the hyperbola as the x and y axis, we have to determine the equation of hyperbola stem 2. First we have to convert this. From there we get x square divided by 2 root 2 whole square plus y square divided by 2 square is equal to 1. And then a is equal to root 2 root 2 and b is equal to 2. So length of the major axis is twice a, which is 4 times root 2 units. Then part B, let P be any point on the ellipse and focus S minus 2, 3, and PM is the perpendicular distance from the point to the directrix. By the definition of the ellipse, we know PS is equal to EPM. So from here, we have to apply the distance formula. PS equal to root over x plus 2 whole square plus y minus 3 whole square is equal to 1 by root 3 times mod x plus 2y minus 1 divided by root over 1 square plus 2 square. After squaring both sides and calculation, we get our required expression. In part C, we have to find the equation of the hyperbola. We are given the equation of hyperbola is, we have to assume this first, then considering the transverse axis along the x-axis according to the condition 2 as a is equal to 18, so a is equal to 9, a square is equal to 81. If we substitute e by root 3, then we get a square is equal to 27, and similarly e is equal to root 3, so e square is equal to 3, a square plus b square by a square is equal to 3, so b square is equal to 54. So required equation of the hyperbola is x square by 27 minus y square by 54 is equal to 1. Okay, now a problem from mechanics. Here in our problem, a string of length x centimeter is attached to a vertical wall and a point on the surface of a uniform sphere of radius x centimeter. Two equal forces P are acted at an angle alpha at the point, and the resultant is inclined at an angle theta, so that theta is equal to alpha by 2. If the weight of the sphere is 8 kg, and determine the tension of the steering of the stem 1. If the three forces of the stem 2 are like parallel and the point 1 in center of the triangle, we have to prove that P, Q and R is equal to ABC. Let the forces P and Q, where P greater than Q, act at a point O. Their resultant is R, which makes an angle theta with the line of action of the force P. So tan theta is equal to Q sin alpha divided by P plus Q cos alpha. If P and Q are equal, then tan theta is equal to P sin alpha divided by P plus Q cos alpha. Then sin alpha divided by 1 plus cos alpha. So 2 sin alpha by 2 cos alpha by 2 is equal to 2 cos square alpha by 2. So tan theta is equal to tan alpha by 2, and theta is equal to, which implies theta is equal to alpha by 2. Now in part B, tension of the string is T and weight of the sphere is 8 kg, which acts vertically downwards through the center. Thus the forces T, 8 kg and are in equilibrium at the point O. According to Lami's theorem, we get T by sine. This T by sine angle between these forces, another two forces sine r and w, and similarly 8 and sine angle between other two line of other two acting forces, and r divided by line of action of other two forces. So t divided by sine alpha by 2 is equal to 8 divided by sine pi minus theta. So t is equal to 8 times 2sx divided by root over 3x square. So t is equal to 16 by root 3. And then part C, q times bd is equal to r times cd. So q by r is equal to cd by bd. cd by ad is equal to bd by ad. Sin dac by sin c is equal divided by sin bd by sin b. So we get sin b by sin c here. So q is to r is equal to sin b is to sin c. Similarly, r is to p is equal to sin c sin a. P is to q is equal to sin a sin b. So we get p q r is equal to sin a sin b sin c. So p by sin a q by sin b is p by sin a q by sin b and r by sin c are equal. P by a q by b r by c are equal. So p q r is equal to a b a is to b is to c. These are the problems for today. I try to discuss with you, explain with you easily. I hope that this will help you to understand the topic easily. Please let me know which problems or from which part I should discuss with you, and subscribe my YouTube channel. This will motivate me to make more videos for you. Thank you everyone.